Hi, we are going to talk a new chapter, Magnetism and Electromagnetic Induction or Electromagnetism. North-south only it exists. You cut the magnet into two. North separated, south separated, sir. You cannot separate. Tangent. Tangent direction only magnetic line direction. That is called the magnetic flux. B is called magnetic flux density or magnetic induction. A is called area. Number of magnetic lines passing through a given area is called magnetic flux. Number of magnetic lines per unit area, if you talk, means magnetic induction. Means iron powder. Very small amount, you place it throughout on the cardboard. Cardboard you are holding like this. Current conductor and all you cannot hold. You will get a shock. We are not putting like this. This is called the Margadi Mand Rangoli. Margadi Masan Kolam Podramar Ni Pod. Tortoise Kosu Tichurul. It is forming by itself. When you talk about a magnet, surrounding the magnet, there exists a region that is called a magnetic field. The lines coming out of it, we call it as magnetic lines. Generally, you take a bar magnet. Bar magnet means it is man-made magnet only, artificial magnet only. It always exists as a dipole. Di means two. North-south only it exists. You cut the magnet into two. North separated, south separated, sir. You cannot separate. Always north and south together only. When you cut it into two, this side, this end will become south, this end will become north. Again, it exists as a dipole. Sir, small piece I am cutting. Smallest piece, even a point. Point one end is north, other end is south. There is no question of monopole. North pole alone, south pole alone. You cannot talk here. Electricity la nee paathirkalam. Plus Q. This electric lines originate from positive. Negative separately you can have coming towards negative. Together also you can have in charge. Positive to negative. But in a magnet, always it exists as a dipole. Every side, north pole, south pole, it has got a strength. It depends upon the type and size of the magnet what you are using. Magnet size is different, means the magnetic pole strength, north pole side or south pole side. Pole strength will differ depending upon the size and shape of the magnet. Formula for pole strength, formula for so-called magnetic moment and all. Second part we will do. First part only the basics we are doing. Sir, when you take a magnet, what are the properties of that magnetic lines? Magnetic lines always originate in north, terminate at south or end in south. Always it is curved lines. Magnetic lines are curved. They never intersect each other. Magnetic lines never intersect. Sir, magnetic line I want to find out. If it is curved means how can I find out, sir? No problem. Suppose at this point I want to calculate magnetic line direction. Draw a tangent. Direction of tangent will give you direction of lines of force. Anywhere curved, this point, tangent. Tangent direction only magnetic line direction. Okay. Magnetic lines are crowded. Magnetic lines are far apart. Crowded means more magnetic lines, more magnetic induction. Magnetic flux density, we will talk about it, is more. Far apart means magnetic lines are less. Magnetic induction or magnetic flux density is less. Okay, Mama? So this is a basic information regarding a magnet and the magnetic lines. Earth magnetism and all, later on we will discuss. Okay, now magnetic flux, a new term. We will represent this magnetic flux by a letter phi. In light chapter, we will discuss this one as phase difference. Second part of light, we will discuss phase difference. PHAS, not FAC, PHAS. Okay. Suppose irregular shaped magnetic lines are passing through this given area. How many number of magnetic lines passing through in this area you calculate? That is called magnetic flux. B is called magnetic flux density or magnetic induction. A is called area. Actual formula is BA cos theta. We are not discussing about that cos term here. Product of magnetic induction and area is called magnetic flux. Unit is Weber. Magnetic induction or magnetic flux density, both are B. B is phi by A. You told phi is equal to BA, so B is phi by A. Number of magnetic lines passing through a given area is called magnetic flux. Number of magnetic lines per unit area, if you talk, means magnetic induction. Given area means into A. Per unit area means divided by A. What is the unit? Weber per meter square or Tesla. Unit of magnetic induction, Weber per meter square or Tesla. Okay, ma? So this is the basic information regarding the magnetic flux and the magnetic flux density. Sir, you are keeping a charge plus Q in a magnetic field. Force experienced by a charge in a magnetic field. Definitely the charge will experience a force. I have a charge plus Q. You are keeping this charge in a magnetic field. This is X, Y, Z. All the three are mutually perpendicular axis. Magnetic induction B along the Z direction. You are keeping a charge Q. Then this charge experiences a force. It is moving at a velocity V in the XZ plane. Then the force for your level, we need not explain the theta value here. General formula alone, I am going to write here. It is the product of three things: magnetic induction, charge, and velocity. F is equal to BQV. Direction of force depending upon the rule, Fleming's left-hand rule. We will discuss about it. Sir, one charge alone, how can I take? I am going to take a conductor. It has got so many charges. Conductor has got a length L. Then in that case, what is the force? Force experienced by a current carrying conductor. Same formula, same concept. Here you are keeping the conductor. This is B. This is conductor of length L carrying a current I. Then the formula says F is equal to BIL. Magnetic induction into the current into the length of the conductor. Detailed derivation, second part of electromagnetism we will discuss. F is equal to BIL. Actually, a theta factor should come there for your level. I am not talking about theta factor. Actually, BIL sin theta is a formula. BQV sin theta is the formula here. For simplicity, I am omitting that sin theta concept for this lower level. Primary level. Not lower level, primary level. Okay. You told something about Fleming's left-hand rule, sir. What is the meaning? Sir, you are keeping a current carrying conductor in a magnetic field, then it experiences a force. So magnetic field direction, current direction, force direction, all the three have to imply. What is the meaning? Fleming's left-hand rule. Forefinger, middle finger, thumb. Keep all the three in mutually perpendicular direction. Forefinger, direction of magnetic field, B. Middle finger, direction of current. Thumb represents motion of the conductor. Extend the first three fingers of the left hand in three mutually perpendicular direction. Forefinger represents direction of magnetic field. Middle finger represents direction of current. Then thumb represents direction of motion of the direction of motion means direction of movement of the conductor. It experiences the force means it should move. Direction of motion of the conductor. Correct, Amma? So this is a basic information regarding a charge or a conductor placed in a magnetic field. What is happening? Sir, I am keeping two conductors. One conductor carrying current I1, another conductor carrying current I2. Both current direction is same. This current carrying conductor placed in a magnetic field definitely will experience a force using this Fleming's left-hand rule. This current carrying conductor placed in a magnetic field experience a force. So you are going to get attractive force if current direction is same. Suppose current direction is opposite, I1 and I2. You are going to get a repulsive force. Fleming's left-hand rule, if you apply, you will get it. Detailed explanation in the second part. If current passing through in the same direction for two parallel conductors, then it will be attracted. If two parallel conductors carrying current in opposite direction, then it will execute a repulsive force. Basic information. Correct, Amma? Fine. Next. Attraction, repulsion. Okay. Oersted experiment. Basic experiment. Sir, you told you are not providing magnetic field here. Magnetic field is existing by itself. Whenever a current carrying conductor is placed, there exists a magnetic field. Oersted, while demonstrating this concept, he was teaching something regarding the current carrying conductor. On the table, he has kept a small magnetic needle. On the table, when he is performing one experiment where current is flowing, that magnetic needle is getting deflected. Magnetic needle, for some other explanation, he has kept on the table. He was passing current through this circuit only to explain something about electric concept. Magnetic needle is deflecting by itself. Whenever the current is passing here, there exists a magnetic field on the side. It is clear. So he started experimenting in detail whether magnetic field is existing or not. Yes, it is existing. Finally, he found out. How, sir? Suppose you take a current carrying conductor, take a cardboard, small hole. Through that hole, you allow the conductor to pass through. Small iron fillings means iron powder, very small amount, you place it throughout on the cardboard. Cardboard you are holding like this. Current conductor and all you cannot hold, you will get a shock. So separately you are keeping. Cardboard alone you are holding on two ends. Through the center, current is passing through the wire. Then after some time you can observe the iron powder or iron fillings what you have placed on the cardboard will arrange itself in concentric circles. You are not putting like this. This is called the Margadi Mand Rangoli. Margadi Masan Kolam Podramar Ni Pod Tortoise Kosu Tichurul. It is forming by itself. If there is a magnetic field, only it can happen, sir. Otherwise, it cannot happen like this. Once a magnetic field, if you observe, then next question, which is north, which is south. Whether clockwise it is flowing or anti-clockwise it is there and all you have to talk. Simple. For that, you can take thumb rule, right hand thumb rule. Extend the right thumb. Direction of the thumb will be direction of current. Direction of curling of finger. Finger is curling means see this finger, which direction it is curled? Anti-clockwise. Like this. Anti-clockwise. Anti-clockwise direction. Upwards means anti-clockwise. This is magnetic field. This is current. Thick arrow. Small thin arrow means magnetic field lines. Sir, here you see coming downwards, anti-clockwise, here upwards. You keep a magnetic needle, both the sides. North to south only magnetic lines now. So this, where it is starting, north, where it is ending, south. Here, down to top. So here, bottom to top, down to up. So north, south. Here I will put there. Okay, you put. Okay. South to north is coming. Talk only about this or talk only about not these two. Correct, Dama? So there exists a magnetic field in the surrounding when a current is passed through a conductor. This is called Oersted experiment. The direction of magnetic field can be given by two rules. One rule is right hand thumb rule. Right hand thumb rule. Underline. Left hand means it is different. Right hand thumb rule. Ampere swimming rule. Next part we will discuss. So you need not provide magnetic field at all. Two wires carrying current means because of this current there exists a magnetic field here. Because of this current there exists a magnetic field here. So attractive force using Fleming's left hand rule.